robotics, and after that we'll do AI introduction. So, do you know about robotics? Okay. Okay. So, okay, like a robot. A robot. Yeah. Don't know if you've seen any online, but there are machines that let's just say basically just a machine that can think, that can sense, think, and act. So what do I mean by that? So a machine that is able to get data from the environment, process the environment, and act on the environment. So how do I define thinking? I can say it's a programmable machine that if you want to, let's say, include AI into it, that can get data, process the data either by a human programmed software or an AI model and act on it. So there are different examples of some robots that are already in the market. Okay, let me not say in the market, that are already out there. Okay, so okay, that's my um okay, there are some robots that are already out there. So applications of robotics, you can use robotics in a lot of industries, and it's like a how do I call it? It's a very sought out. It's um, it's something that is sought out by a lot of industry, a lot of sectors, like in their agriculture, mechanized robotics, farm. Like a friend of mine, she works in ST Robotics in the UK. So what they do there is robots handling your planting and harvesting. So the the robot looks like it's just like a base, mobile base with an arm and some sensors. So what it does is go through your farm, plant your seeds or seedlings, and when time for harvest comes, you adjust the robot to handle harvesting and it does harvesting for you. So that's like in the agricultural sector. There is manufacturing. All the cars you see out here. Okay, let me not say all, but majority of the cars, because there are some luxury cars that are handmade, handcrafted to a large extent. But majority of the vehicles you see, for example, are made by robots, and those are like the manufacturing robots. They're just like they can be arranged into different configurations, but it's mostly in different sectors. There will be an arm. The arm will be responsible for welding. So it's just an arm like that, but very flexible and dexterous. So it has a welding touch at the end. Just welds your robots and all that stuff. Those stuffs now are also controlled by AI because they work in a very complex environment and you need AI. You can't just let me use the word chaotic environment. You can't really just code like the whole aspect of it. You can't to a large extent, but with AI it becomes easier. So in the manufacturing sectors, there's robots like that, spray painting robots, robots that will spray different types, robots that build houses. There's a new robot, I've forgotten the name. What is still a mobile base, like a vehicle, or has a big arm, lays blocks, cinder blocks to build your house. Like human beings build, a house that a human, like sets of human beings can build in months. This robot will do it in days or weeks and complete your building for you, very accurate and neat. So that one is there. Then space robots. Have you heard of Curiosity? The Curiosity robot. So this is like another application of robotics where places that are too harsh for humans to go, the robots can go there. Example is space, underwater. You know, um, you know the Titanic. When the Titanic sunk, and when they went to explore the site, they used a rover, not a rover, ROV, remote operated vehicle, or you unmanned underwater vehicle. So they control it from the mothership and it goes down and explores. It has arms, you use it to take things apart. So those kind of things. In space, the Curiosity rover is on Mars. I think there are two models of it on Mars. What it does is it gathers samples and places, analyzes them, puts some back together and send it back to Earth. So those robots for exploration, even in the space station, there is a robot there. There are robots there. So it's very useful. It's a very important field because now that everybody is applying AI and we are trying to make because a robot now in a work setting is more advantageous than a human being. So a robot will, you know that these things that they say AI will take over. AI will take over your job and all those things. One part of it is through robotics, where labor, AI will like robotics will like take over a big part of labor force. And what's a better point to stand if not being the one programming these robots, if not the one making these robots? So that one is that. Another application of robotics, medical field. Imagine you are a very good surgeon now, and there is an emergency in the UK and you're in the US. How would you perform such? Let's say you are like one of the few people that is able to do that and save a life, but you're in the US. Or with there are surgical robots now where you will be in US and you'll be performing surgery on somebody in the UK because telemetry. So your ability to remotely operate a robot. So that one is there. That's also an application of robotics. So there's another one, another application, autonomous vehicles. So okay, let me not even go to Tesla, cyber vehicles. You know Cybertruck, self-driving cars. That's an application of robotics. A friend of mine works at Lucid. You know Lucid Motors. Yeah. Yeah, he works there. So it's part of the ADAS team. So they do navigation. So all these self-driving vehicles, you have to do robotics to be able to do that. So looking at the robots, there are different parts of the robots. Like you said, like important major parts, or should I call it a major part, or let me just say some of the important parts of a robot according to what we define it as is, you know, senses, it thinks, and it acts. Okay, so here, let me even use this our make block kit to just probably just give you like a break, let's say a breakdown, like just show you those different sectors of the robot. So here, you can have different configurations of this robot. If you check the manual, there are different configurations. So here, we said uh, can sense. So here you can see some of this stuff here. This is an ultrasonic sensor. So what it does is to tell the distance of an object. Because you know, these robots, they work with data. Just like you know, let's consider you now like a machine, a sophisticated machine that works, that interacts with the environment. You sense the environment and you act on it. Let's say your eyes are for vision. You use it to see this thing, then you control it and pick it up with your hand. So in a robotic settings, your eyes will become the sensor. So there are different types of sensors, like for visual purposes. There's camera. So cameras will just, you know how cameras see with your eyes, they give a visual representation of the data. So this one is an ultrasonic sensor. So what it does is, have you heard of echolocation?
Echo.
Yeah, echolocation. You know, in physics, there's one thing that we used to do then. Is it physics? Where they'll tell you, oh, calculate the depth of this well.
Yeah.
They tell you to clap. You time it, and when it goes down and comes back, you do a distance over time. Speed, velocity equals to distance over time. Yeah, that's the formula. Then you divide by 2 for going and coming. Yeah. So that's what this stuff does. It sends a high pitch sound, sends it out. Let's say you want to, it's going around, but this is useful for an obstacle avoiding robot. Let's say you are moving and this guy, the function is to sense, because it has a 120 degrees field of vision. So depending on the distance. So with this, you can try to keep minimum distance here. It's just in your code, whatever you decide. So this guy, what it does is to send a high pitch sound, high frequency sound. You cannot hear it. Sends it from the transmitter. These two transducers, they are piezo transducers. So one does transmitting, one does receiving. It's just like the mouth and the ear, where you say something and you're able to hear, that kind of thing. So sends the sound bounces off the nearest object that is being targeted at, and it comes back to the receiver. So this stuff calculates the timing it takes for this guy to go and come back and use it to estimate distance. So that is like one type of sensor, as if you are trying to include obstacle avoidance. And there is a real life application of this. You know, in vehicles now there is collision detection, or should I say prevention, where if you are too close to a vehicle, the closer you are, the faster you hear a beep. So this is the device that we use for it. So that one is one of the sensors for the robotics. So and in this robotics class, will give you like because you need some knowledge of electronics, you need some knowledge of programming to be able to like fully participate in it. So do you have any experience with electronics or programming?
Programming.
Yeah.
YouTube.
Okay, what language do you program?
It's not like I was learning before.
Yeah.
That's um, web design that this guy is teaching.
Oh, web design. So
Web design.
HTML, CSS,
Yeah.
JavaScript. Oh, okay. But here we'll be doing more of C++ and Python. Yeah, C++ and Python. So C++ is a compiled language, very fast and powerful. Python is interpreted and very useful for AI purposes. So this part now is the brain of this robot. So it takes the data from the sensors, processes it, and sends signals to the actuators. So we talked about a sensor for this guy. So there is the brain, which is this. So there is a microcontroller and there is a microprocessor. Do you know what microcontrollers and microprocessors are?
Microcontroller.
Okay. Like a microcontroller is a small computer. Let's just say a very small computer. It has the basic peripherals of a computer, the central processing unit, a main memory and a secondary memory, and IOs, that is input and output. So microcontroller has it in built in. So here, this is based on the Atmel 80 mega 2560 chip. So that's the main microcontroller here. So it's very useful for this purpose. So it has a lot of inputs and output pins. So we'll learn how to program those stuff to be able to use it to interact with the environment. And one good thing about it is if you know, because we're going to teach you how to use these components individually. So if you know how to use them individually, you, even if you don't want to apply them to robotics, you can apply them to any other thing. Let's say, for example, um, home automation. Do you know about home automation? Okay, so home automation is it's a very it's a very interesting field. I do some home automation stuff. So let's say, for example, you just enter here and all the lights come on for you. Very convenient. You don't need to go and start pressing button, pressing switch. You come in, your AC comes on, depending on your preference. If you prefer, let's say you prefer here a bit cool to some temperature, once you come in, it does that for you. Yeah. So that's like things you can just even consider the house like a robot. But if you have that knowledge from this course, you'll be able to apply it to things like that. Home automation, just IoT. So those are like knowledge that we're going to give you here, because IoT, Internet of Things, where every device, that's the goal, every device is connected to the cloud and they're able to interact on data. You understand? So those are like your takeaways from this for us. And so this week we're just going to give you like a basic introduction to electronics. Then we're going to do um, some programming also. Okay, so components. We have done the brain. Then there are the parts that you act on, which is we call it the actuators. The actuators of the robots are like the mechanisms that enables it to move in the robot. So here you can see these two. This one's now are the motors for the tracks. It enables the robots to move, steer, and then this one is for the arm to raise and lower it. So this one is only able to raise and lower. So I can just call it like 1 degree of freedom. So you can only raise and lower to pick up. One application of this particular one is just to pick up stuff and go and put it places. So in there is a robot, I've forgotten the name, but it's a vacuum cleaner, just like the Roomba. What they do is, robotic vacuum cleaners, they just stay in the house and clean your houses for you. These are like things that consumer products that you can make from robotics. They just go clean your house whenever it's dirty. They clean your house and go and pack themselves. There are lawnmowers. Let's say in this case now, you come to Uniben and just be like, oh, I want to design lawnmowers for you for your grass. You just bring them out here. They give them. They usually have a dock, solar powered dock, where once they start cutting, they automatically go and charge themselves. Or drones, the Amazon delivery drones or Amazon food delivery stuff. Those are like very important parts or applications of robotics. So these are the actuators. Then there is end effectors. So in this system, you can see this one now. This one is called the gripper. So it's an end effector. An end effector is just that part of the robot that is actually used to interact with the objects in the environment. So what this one does is to pick, like, this is a gripper, to just grab. This comes together, it grabs and picks it and stuff. So there are other types of end effectors, like we mentioned earlier in the welding, in the manufacturing of vehicles, the welding robots. The end effector is that tool at the end that it uses to perform its duties, which is the welding torch. So it welds it, you see weld, something like that. So that one is a part of the robot.
Have you started?
Yeah, that one is another part of the robot. So to achieve all this, because I'm going to like reference the human body a lot. The human system, the human body is made up of different systems. Where I think it's called taxonomy in biology. The human, different system, respiratory system, digestive system. All those stuff, they perform particular tasks in the entire body. So yeah. So this partner, you can call it a system for movement. Then combination of all these ones now conjoined before the arm and all this stuff. So we have systems. There's this one, for example, there is a sensor inertial measurement unit, that is the IMU. You can combine it with different other sensors to what do I call it now? To form a system. Because like you now, as a human, you are aware of your body right now. You are aware of the orientation you are sitting, the position of every part of your body with respect to maybe your core. So your hand is crossed, you are sitting, your back is upright. So a robot also needs to know that. So those are where different sensors come in place and they work as a system in order for the robots to perform its task. So there are different components that we're going to introduce you to just be part of the system. You have some here. So we're going to use these guys. We're going to use these guys to these are the components. We introduce you guys to it.
What is water?
Hmm?
fixing it.
Yeah, I think the drain maybe is clogged or something. Maybe the pipe is bent.
Yes.
Okay. So here in this part, there are just different sensors, and the knowledge on how to use them will make it easier for you to combine them and build something practical in a robot. So for example, okay, these ones are the discrete components. They help you to just put things together. Okay, you see this guy? This guy is an ultrasonic sensor. So this is the development module aspect of it. So what we're going to do is we're going to teach you how to use these guys individually. Then we put them together to operate the robot. So this is an ultrasonic sensor SR04. You can see the T and the R. So this is the transmitter where the sound comes from. This is the receiver where it receives it from. So this is a PIR sensor. So this is PIR pyroelectric infrared sensor. So what it does is to sense the change in infrared. You know, living bodies like you now, you give off a certain level of infrared, you emit a certain level of infrared rays. So what this does is to sense that change, senses it and is able to signal. So these guys now, let's say for example, I mentioned when you come into the room, the light comes on. This guy can do that for you. So let's say you want to automate your bathroom, for example, at night that you want, sometimes when you want to go and eat yourself, everywhere is dark. So this one wants to just open your, let's say, bathroom door. Turns on your light for you. You don't even need to start looking for anything. Just open your door. Turns on your light. When you go out, it will wait for a while. It's a time set by you to wait and turn it off. You can use it here too. So you can use it in a way that let's say it's a robot that performs an activity when you come around, when you are inside, maybe get you something. It could be the robot could just be in idle state, asleep. Then this stuff will just be active. When you pass, when you enter, it comes on and alerts you or performs its tasks. So this is these are just sensors that you can just combine to do whatever you need. This is a soil moisture sensor. So it senses the moisture level of the soil. You can maybe take a look if you need to. You can just check them out. So what it does, this works with Ohm's law. It's actually, you can say it open. It actually measures voltage drop with resistivity of the soil. Because the drier the soil, the less conductive it is. So that's what that guy is working on. So this is a servo motor. So in robotics, there are just different types of motors that we can use. For example, this is just a DC motor. There are different types of motors. There is the DC motor, there is the stepper motor, there is the servo motor. They all have their specific, they have the aspects where they shine. They have aspects where they shine. So there was a robot that I worked on, my friend, I think 2019 in Univen. We used a lot of this guy for the arm. So it was like a scorpion-ish robot that you just control around, picks up stuff, throws it out, and all this stuff. And we use these guys a lot. So this is a servo motor. So it has 3 wires. The power, you can take a look. The power, positive and negative, and the third wire is the signal wire. So it moves to specific angles. You just tell it what angle to move and to move. It's just like if you use it for your arm now, because the robots are just like I mentioned, they are systems just like us. Our arms now move, and when it moves, each joint at a specific angle related to other joints. So for me to get this position, it's just a combination of different joints, different angles. So these motors, they move at specific angles when you instruct them to move at a particular angle. They just move to that angle exactly. So that one is a type. This one is another type. This one is a DC motor. Then here it has a gearbox. So DC motors are just brush DC motors are just the regular motors that we know. You just put DC power to it and it starts spinning. So, but this one has some extra add-ons. This is the gearbox. So for this system, for this guy to be able to lift stuff, he needs to have enough torque at this point. It needs to just be strong enough. So there's a gearbox here. So this is a reducer gear. What it does, once you gear a system, if you gear it down, the torque goes up while the speed comes down. In this gear, the speed comes down while the torque goes up. So at this point, it has more torque than the input shaft. Also, you can see this other gear here. This is also a reducer gear to increase the torque because in I think mechanics movement. Yeah, so the load here is massive at this point, moment of force. So you need a lot of force here. So we get it down to as much as for this guy. So this is a DC motor, and here it has an encoder. So an encoder is another type of sensor. So what it does is to tell the speed and direction of rotation of a shaft. So in this case, it's for this DC motor. We're going to deal a lot with it, so you get used to it and how to use them. So there are other types of motors. There's a stepper motor. So this type of motor moves in discrete steps. So it doesn't rotate easily, just rotate continuously. It moves in steps, clicks. And these steps, they have specific degrees that they move. So those ones, it just goes on the application. That type of motor is easier to use as a rotating base. Let's say your robot, you have a robotic welding arm. There are some robots called SCARA. So you have a robotic welding arm that the base needs to swivel. So just like these joints. So there are different types of motor that you can use. They can use this motor there and just keep rotating in specific degrees that you can predict. So there's also a brushless DC motor. That one is a very cool type of motor where it uses you call it DC motor, but the waveform that actually enters that motor is kind of modified DC, so it's like an AC. So that one has good torque, good speed, but the angles, precision of the angles, you need to do some magic to be able to be precise. So depending on the best fit for your system, this is a temperature sensor. So DHT. This is DHT22. This should be DHT22. So digital humidity and temperature sensor. So what it does, it tells you the humidity of the environment and the temperature. So if your system requires that as a parameter, you will use it to operate on it. So let's say, for example, I'm going to just use an automation example for this. Your house, you have a fan, have an air conditioner, you have a humidifier, and you want it to be at a specific setting. Let's say the relative humidity is like let's say 60% or 70% that you want it. If it's too high, this guy will sense it and it will turn off your humidifier. If it's too low, to just so that's like the application of this. So you can use it to build your smart homes and all this stuff. Then these are displays, they are output devices. So they just give you feedback to your system. So there are other ways you can give feedback to your system, but this one, let's say it's in your robot or your house or your electronic system, can give you the current parameters of the system. Let's say battery level, any other metrics that you want to track. So this guy can do it. This is another display. This is 7-segment display, and this is a 1602 LCD liquid crystal display. Alright, so this is a water level sensor. You can still use it for your systems. It's just things that you use to sense different kind of any kind of parameter on your environment. This one is a relay. So okay, let me explain. Let me look for a good way to explain this. The brain of these guys, they work at low current. They don't really carry much current. For most cases, we need it to control things that are very heavy. Imagine, okay, I'll give you an example with this guy, then I'll give you an example of like a real scenario. These guys, you see these ones, they are motors and they require high current to move. These guys, this one, this is the control board. The microcontroller inside doesn't generate much current. For example, this is an amp mega, so the output current is 40 milliamps maximum per pin, and this guy can take up to let's say 3 or 4 amps. Can take up to let's say 3 amps because it's smaller than this. Let's say can take up to 3 amps. 3 amps is actually 3000 amps. So this needs, how do we use this guy to control something that is hundreds of times more, like hundreds of times heavier than the pin? That's when we use things like that relay or this one, motor drivers. So they take the small signal and use it to control a bigger signal. So here, these motor drivers have internal transistors. This is like a transistor or a small version of this one inside. So they take small input signal and amplify it and use it to drive motors like this. Another application of this now, especially for this relay, is when I told you when you enter inside here, the lights come on. This stuff, they use battery power. When you plug it in direct to NEPA, so just kill it, using it to control volts, so just kill it. So what we do, we take these guys, power it a low voltage, connect these guys to it. So these relays now, they have like an electrically controlled switch. So what it does is it puts in signal and it clicks on. Okay. Let me see. I'll just do a simple demo first. We'll continue. Alright, so this is a relay. So if you can see here, these small ones are for the small current that enters to power the big ones. So these ones now can carry up to 10 amps. So you can use it to power your AC and control it. So I'll just send power to you. See where comment a load yet. So this is something we'll do when we were being introduced to programming, because we need to program first. So this is an Arduino Uno. So it's like a younger cousin of the brain here. This is a Mega. So it's the microcontroller used in Arduino Mega. Alright. So these are jumper cables. So when we prototype, when we build prototypes, we use these guys to make temporary connectors. So here, so if we let's connect this guy. So I'm just going to use my computer to. Alright, so this guy is the positive, this is the negative. So you can see that there's the next one, signal. Let me use the black for negative. And the brown for signal. So black goes to negative. So this is the signal. You can see this guy is off. We have an altimeter here. We don't have another. Let me first of all test if there is power inside here, inside the wire. These stuff were not tested earlier. So this is a resistor, helps us to reduce current entering the system. It's an LED. So this is another form of output device. Okay, well this value is quite high. Oh, let me see. Alright, so I'll take off power here. I'm guessing this wire is bad. I'm guessing the wire is bad. Let me connect them directly and see. Plus and minus. So this is P13. or this guy is the ground. Let's try again. This wire might be bad. The wire is bad. The wire is bad. The wires are bad. Let me just confirm the wires before we continue. It's important that these wires are good. These wires are bad. We get another set. These wires are broken inside. These wires are bad. Comes on there, but the wires are not good. I have my own pair, my own set in the house, so when I'm coming in, I'll get them. These wires, man, should have tested them before the class, so that's not bad. So, these wires are just interesting. It's actually interesting. So we have two. We've got it, so we need one more. So we're going to, so the black is the negative, connected it to ground. So, white is the signal, then we need the positive. Was it this set collected from? So let's try this as a positive. can hear the clicking on the switch. So we're using electronic signals like on an electronic level to click the switch inside. This is a relay. Call it an electromechanical switch. So the same signal here, it clicks the switch inside. So just like your house, like in our normal switches, we have normally open, normally closed, and the common. So connect the wires. If we take apart this bulb now and connect this wire, we'll be able to use this guy to control this light here. So that's like wire shaking. But you get the idea for this guy. So this is like a basic. You can do more complex things with this one. So that's where sensors and actuators come. So this actuator is what helps this brain to act. So it helps it to turn on the lights, turn on the motors. Yeah, this is a sensor that helps this guy to receive signal, to sense when you come in. So you can combine this and this into a system, like a lighting system for your house, where this guy controls this guy. Or you can combine this one, which is a temperature sensor, and your fan to be able to work automatically, because like a robot, it's just a machine that you program to think and act on its own. That one is there. So these ones now, they're just basic components that you put together to.
Who do I talk to?
I'm just telling you.
These are like basic components that you put together to make a sensor or just do something in your system. For example, this is an LDR sensor, light dependent resistor. So what it does is the resistance. Do you know what a resistor is? Okay, so a resistor is something that opposes the flow of current. So this one, the resistance, which is the amount of resistance it can offer to an incoming voltage to generate the current, it changes with respect to the amount of light in it. So you know Ohm's law? Yeah, so if you take this and a mathematical application of Ohm's law, you'll be able to convert this into a light sensor. Let's say you want to build a solar tracking system. Do I have a video of prototype? So a solar tracking system, let me just see if I do. I don't have the videos of all this stuff on my phone. Let me just see. Well, I don't have the complete setup. I don't have the complete setup for. Okay, this is a prototype. This one is a prototype. This one is a prototype. Okay, I'll show you this two. This is just a prototype, so it's like a proof of concept. You can see this and this. They're like a bigger version of that sensor that I gave you. So what it does is it senses light, it moves towards the direction of light. This is just for your solar system. It helps you to track the sun. So every time the sun is out, your solar panel is on its facing. These are like applications of where you can apply things that you learn from here. So you can see this here and here. So you can see this guy and this guy. They look very similar to this one. So this one is what helps to move the what's it called, the solar panel. So it's the servo motor that helps to move the solar panel. So these are just like the different applications where you work on those. I don't know if okay. So, you know a 3D printer?
3D printer.
Yeah, so that one is a part of the CNC machine. So you can use knowledge from here to even build a 3D printer. 3D printers are just made from this guy. There's a 3D printer, the Prusa 3D printer. The main microcontroller is the Mega 2560. So still the same with this. You can actually make a 3D printer from this particular board because it already has 4-stepper motors. So you just connect it and you're able to get the X, Y, and Z axis, then the extruder. So this board itself, if you want to make a 3D printer, you can make it from this guy. Okay, so this one, I don't think I have a video of this one. You can still see this servo motor here. So this is like an automatic trash bin. So when you walk towards it, it will move for you and you trash your bin. Let me see, let me search if it's there. I changed my phone, so if you look at it, so if you come close to it, to open for you and show it. So you can deploy stuff like this. This one now, like I mentioned, sensing and acting. It senses with this guy and it acts with that guy. So stuff like that, that's how you combine them. And so we're going to teach you. So today's class is just basically just introduction on things that you're going to expect from here. So teach you how to program, then basic electronics, where you know how to combine different components to make something work. Let's say the use of a MOSFET and a transistor or resistor in order to control a motor. Because these guys, they can't control motors directly, so you need a driver. So these guys can do it and all this stuff. So this is a potentiometer. Do you remember potentiometer in physics? Yeah, so this is a sample of it. So what it does is, depending on your position of this guy is called the wiper. Depending on the angle, there is a resistance between these 3 pins. It changes. So we use that a lot in our everyday life, not even just robotics. Let's say volume control for old radios there. It has it there. And something a lot of us know, gamepad. You know games? You know that analog stick? Yeah, I mean it's something like this. But with spring that returns to the middle. So those are things that you use to interact with. Just like games, you use it to control characters in games. You can use it to control robots. For example, the robot dog, Spot. Do you know Spot? It has a controller, handheld controller, that looks like an Android phone. Yeah. So those are things that you use to control robots. And then there is robot a burning house like that, it's very dangerous for firefighters to enter. A robot can easily enter, and first of all, if the robot gets damaged, you can repair it, or it's no big of a deal than human life, and it can navigate harsh environment and turn off your fire for you. So that one is there. I want to do that electronics. Next class we just do some introduction to electronics and all those stuff. Do programming, for a while. You need to know C++. You can use other languages though. You can use C. You can use C is if you are focused on the, let's say, electrical part of the robotics. If you are focused on the software part, it's better to use C++ or Python. So we'll soon be rounding up. So you can use C++ if you're focused on the software part. Then the AI part. Python is very good with the AI. There's Python, MATLAB, and all those stuff. For scientific purposes, use your MATLAB. So we're going to introduce you to more C++ and Python in order to use this robot. So there are many software tools that will introduce you to for robotics. Like you mentioned, your concern was having to buy materials. So yeah. So for robotics too, you can easily do robots projects without buying the robot itself. So there are simulators. It's just that it's a bit fun when you build it and you're able to actually, you can simulate the environment, but you're able to control it, feel it, and all those stuff. So there are simulators that we can use. There's Gazebo. So Gazebo is like, it's not part of ROS. ROS is robot operating system, but it blends well with ROS. So there's Gazebo and there's Coppelia Sim. That's Coppelia Simulator. So those ones have industry level robots that you can easily program. And you can do it in Python, you can do it in Lua, you can do it in C++, so you need some small extra modifications. So Lua is also another programming language for the mechanical part. So I think that will be all. We introduced you to, you know, these components. All these components.
Some.
Yeah, like this is the capacitor. Yeah, so stores charges. Then this is a transistor. This is a transistor also, but a bigger one. This one is a voltage regulator. Oh, BTA16. This is a thyristor or silicon controlled rectifier. Alright, so then this is a very popular integrated circuit. That's the NE555 timer. It's a very popular one. So it helps us to, we use it for timing, oscillators. So oscillator in terms of for electronic projects are like very important. They're like clock. It helps them like pace themselves to real time. Let's say for example you want to build a clock with this guy. You need some kind of oscillator that vibrates at a particular frequency.
Okay, you can read a clock.
Oh yeah.
Read this one.
Yeah, you can build anything with it. You can build a calculator with it. You can build a clock with it. So that's like the cool thing about it. Anything you imagine to make, you make it. So those are like possibilities. This one, you can build a radar with it. I think we can even maybe, okay, when we start, we just do tiny projects with it until we get to the point where we do the mini project. So we can take pictures, everything you want to do. So I think after maybe from our next class, maybe when everybody is when everybody are here, start the classes, I will give you maybe links to supporting materials where you can learn more. You still remember the names, no? Are you know with you guys?
Yeah.
So we're going to use these guys to build projects. Projects that you can turn them into real life profession. For example, what's it called? This one now. This is something as small as this. It has been very useful in there are some hotels that require you to they want to know the amount of water they have in their tank, the diesel in their generator, and all those stuff. With this you can just build a product that can just do that for you. You build it, sell it to them, you make your money. So there are just things that you can learn. Are you done with the picture? Coming Friday.
Thursday.
Friday. They have the Monday, Wednesday.
Yeah, I remember.
This physical class is Monday, Wednesday, Friday.
Okay.
For
That means I'm not coming tomorrow.
no, you confirm with him. You might be doing AI. Confirm with him. Alright, so thank you very much for today. We'll continue. I'm coming, let me call him.
Okay.
What do you think is your
Have you stopped?
no?